This is SpaceTime, Series 20, Episode 61, for broadcast on the 4th of August 2017. Coming up on SpaceTime, a new study finds the Sun's core rotates almost 4 times faster than its surface, determining the weight of a distant black hole. And do the lakes and seas on Titan fizz like soda pop? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered that the Sun's core rotates 4 times faster than its surface. The findings, reported in the journal Astronomy and Astrophysics, opens a new window into solar physics, providing fresh insights into the Sun's internal structure and composition. The new findings also contradict previous assumptions that the Sun's core rotates at the same speed as its surface. The rotational speed of the Sun's core is a remnant from its formation 4.6 billion years ago. After the Sun formed, the solar wind likely slowed down the rotation of the outer parts of the Sun. Scientists were able to determine the rotational speed of the Sun's core after first detecting long-sought-after gravity modes of seismic vibration using the joint NASA-ESA Solar and Heliospheric Observatory spacecraft SOHO. Just as seismology reveals Earth's interior structure by the way in which waves generated by earthquakes travel through it, solar physicists use helioseismology to probe the Sun's interior by studying sound waves reverberating through it. On Earth, it's usually just a single earthquake that's responsible for generating seismic waves at any given time. However, the Sun's continuously ringing like a bell, owing to the convective motions deep inside the star. Higher frequency waves, known as pressure waves or P waves, are easily detected as surface oscillations, owing to sound waves rumbling through the upper layers of the Sun. They tend to pass quickly through deeper layers and are therefore not sensitive to the rotation of the Sun's core. Conversely, another type of wave, known as a gravity wave or P wave, represents oscillations deep in the solar interior but has no clear signature on the surface, making G waves harder to detect. In contrast to P waves, for which pressure is the restoring force, buoyancy, or rather gravity, acts as the restoring force for gravity waves. The study's lead author, Eric Fawcett, from France's Observatoire de la Côte d'Azur in Nice, says the solar oscillations studied so far are all sound or P waves, but there should also be gravity waves in the Sun, with up and down as well as horizontal motions, similar to waves in the sea. You can sort of think of these G waves as being like water sloshing around inside a half-filled tanker truck travelling along a windy road. Fawcett and colleagues have been searching for these elusive G waves in the Sun for over 40 years, and although earlier attempts have hinted at their detections, none were definitive, at least until now. The authors used some 16.5 years of data collected by SOHO's dedicated Global Oscillations at Low Frequencies instrument, or GOLF. By applying various analytical and statistical techniques, a regular imprint of G modes on top of the P modes was revealed. In particular, they looked at a P mode parameter that measures how long it takes for an acoustic wave to travel from the surface of the Sun through to the core and back to the surface again. And it turns out that's about 4 hours and 7 minutes. They then detected a series of modulations in this P mode parameter. These could be interpreted as being caused by the G waves shaking the structure of the core. In other words, the 4-hour, 7-minute P-wave travel time changes ever so slightly because of the sloshing motion of the gravity waves. And it's the signature of the imprinted G waves which suggests that the core is rotating once every Earth week. That's nearly 4 times faster than the observed surface and intermediate layers. Because the Sun isn't a solid object, but rather a body made up of superheated gas or plasma, it undergoes differential rotation, meaning different parts of the Sun rotate at different rates. This differential rotation is caused by convective motion, as heated plasma being transported between the core's radiative zone and its surface is impacted by the Coriolis effect due to the Sun's rotation. This results in the Sun rotating faster at the equator than what it does at the poles. When referenced against background stars, the Sun's equatorial rotational period is about 25.6 Earth days, whereas its polar rotational period is around 33.5 Earth days. Viewed from Earth as it orbits the Sun, the apparent rotational period of the Sun at its equator is about 28 Earth days. The idea that the solar core could be rotating more rapidly than the surface has been considered for more than 20 years, but has never before been measured. The Sun's core is where nuclear fusion, the process which makes the Sun shine, takes place. It has a temperature of about 16 million degrees Celsius. while the Sun's apparent solar surface is only about 6,000 degrees. Scientists have previously detected G-waves in other stars, but this new research is the first convincing proof that these waves also occur in the Sun. The rapid rotation of the solar core has numerous implications. For example, is there any evidence of a shear zone between the different rotating layers, the core, the radiative zone, the convective zone, and the surface? Also, what do these periods of G-waves tell us about the chemical composition of the core? And what implications does all this have for stellar evolution, as well as the thermonuclear processes taking place in the core itself? I'm Stuart Gary. This is SpaceTime. Astronomers have used the rotational speed of cold gas clouds in a distant galaxy to make the most precise measurements ever of the mass of the supermassive black hole at its centre. A report in the astrophysical journal Letters claims the supermassive black hole, which resides in the heart of the galaxy NGC 1332, has about 660 million times the mass of our Sun. This new method of determining the mass of supermassive black holes in distant galaxies will allow astronomers to better understand galactic evolution as well as the growth of black holes across the universe. NGC 1332 is an elliptical galaxy located about 73 million light-years away in the southern constellation Eridanus, the River. Most, if not all, galaxies contain supermassive black holes, with debate continuing among scientists about which comes first, the galaxy or the black hole. Astronomers know there's a direct correlation between a galaxy and its central supermassive black hole. By observing the motions of stars around the supermassive black hole at the centre of our own galaxy, the Milky Way, astronomers were able to determine the mass of the central black hole, known as Sagittarius A star, to be about 4.3 million times the mass of the Sun. The same technique has been applied to determine the mass of all sorts of systems, ranging from planets and stars to other galaxies. And previous Hubble measurements indicated that the central supermassive black hole in NGC 1332 was somewhere between 500 million and 1.5 billion times the mass of the Sun. The problem is it's more difficult to determine the exact mass of black holes in very distant galaxies where individual stars can't be isolated by telescopes. So instead, Aaron Barth from the University of California, Irvine and colleagues measured the movement of a vast cloud of cold carbon monoxide gas orbiting around NGC 1332's galactic centre. However, there's a problem. The disk of this gas is so huge it stretches out some 800 light-years, and the outer edges of the cloud are being gravitationally influenced by nearby stars, thereby affecting the rotational speed of gas in that part of the cloud. So, the authors used the high accuracy of the European Southern Observatory's Atacama Large Millimetre Submillimetre Array Radio Telescope ALMA, which is located in Chile, to make the most precise measurements possible of the inner parts of the disk's rotation. Using ALMA, they were able to determine the gas within 80 light-years of the galactic centre was rotating at over 500 kilometres per second. That allowed them to calculate the mass of the black hole to be about 660 million solar masses, about 150 times more than Sagittarius A star. And this is SpaceTime. I'm Stuart Gary. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/SpaceTime with Stuart Gary. New data indicates the hydrocarbon lakes and seas on the surface of Saturn's moon Titan could occasionally erupt with dramatic patches of fuzzy bubbles. The findings came from research at NASA's Jet Propulsion Laboratory in Pasadena, California, where scientists simulated the frigid surface conditions on Titan, finding that significant amounts of nitrogen can be dissolved in the extremely cold liquid methane which rains down from the skies and collects in rivers, lakes and seas. The findings, reported in the journal Icarus, demonstrate that slight changes in temperature, air pressure or composition can cause the nitrogen to rapidly separate out of solution, like the fizz that results when opening a bottle of soda pop. NASA's Cassini spacecraft found that the composition of Titan's lakes and seas tends to vary from place to place, with some reservoirs being richer in ethane and others in methane. One of the study's authors, Michael Malaska from JPL, says the experiments show that when methane-rich liquids mix with liquids rich in ethane, for example from heavy rain, or from runoff when a methane-rich river mixes into an ethane-rich lake, the nitrogen is less able to stay in solution. The release of nitrogen, known as X-solution, can also occur when methane-rich seas warm slightly during the changing seasons on Titan. A fizzy liquid could cause potential problems for any future NASA mission sent to set sail on Titan's seas. You see, excess heat emanating from such a probe could generate bubbles to form around its structures, such as the propellers used for propulsion, making it difficult to steer or keep the probe stable. The notion of nitrogen bubbles creating fuzzy patches on Titan's lakes and seas is also relevant to a number of unsolved mysteries which Cassini's been investigating since its time exploring Titan. The biggest of these is the so-called Magic Islands. During several flybys, Cassini's radar revealed several small land areas on the seas, which first appeared, then disappeared, and in at least one case, reappeared again. Scientists have proposed several possible explanations for what could be creating these seemingly island-like features, including the idea of fields of bubbles. And this new study provides details about the sorts of mechanisms which could be forming the bubbles, that is, if indeed they are the culprit. In characterising how nitrogen moves between Titan's liquid reservoirs and its atmosphere, the authors also coaxed nitrogen out of a simulated ethane-rich solution as the ethane froze on the bottom of their tiny simulated Titan lake. You see, unlike water, which is less dense in its solid form compared to its liquid form, ethane ice would form at the bottom of Titan's frigid pools. And as the ethane crystallises into ice, there's no room for the dissolved nitrogen gas, which then comes fizzing out. Malaska points out that the movement of nitrogen on Titan wouldn't just happen in one direction. Clearly it has to get into the methane and ethane before it can get out again. Malaska describes it as the lakes of Titan breathing nitrogen. And of course a similar phenomenon does occur on Earth with carbon dioxide absorption by our planet's oceans. Cassini made its final close flyby of Titan, its 127th encounter, on April the 22nd. During the flyby, Cassini swept its radar beam over Titan's northern seas one final time. It was that flyby which changed the spacecraft's course to begin its final series of 22 plunges through the gap between Saturn and its innermost rings, known as Cassini's grand finale. The 20-year mission will finally conclude with a suicidal death plunge into Saturn's atmosphere on September 15th. You're listening to Space Time. I'm Stuart Gary. Time now to turn our eyes to the skies and check out the celestial sphere for August on Skywatch. And the constellation Scorpius the Scorpion is high overhead, covering almost a third of the August night skies. At the very heart of Scorpius is the red supergiant Antares. Located near Antares is the globular cluster Messier 4, or M4 for short. Globular clusters are densely packed spheres of thousands of gravitationally bound stars, which were all originally born at the same time in the same stellar nursery. They're usually fairly ancient, as old as some galaxies, dating back around 12 billion years. Located just below the sting of Scorpius are the open clusters M7 and M6. Open clusters are less densely packed than their globular cluster counterparts. That means the stars inside them are less gravitationally bound and consequently more prone to drift away over time. Another open star cluster in Scorpius is NGC 6231, located about 6,500 light-years away, just near the star Zeta Scorpii. NGC 6231 contains about 120 stars, including a significant population of high-luminosity supergiants, numerous white-yellow stars, and at least 2 Wolf-Rayet stars. Wolf-Rayettes, or as some call them Wolf-Rayets, are hot, extremely luminous evolved stars nearing the ends of their lives. Having run out of hydrogen for core fusion, Wolf-Rayet stars are no longer on the main sequence and are fusing progressively heavier and heavier elements in their cores, in the process generating hot, powerful stellar winds and surface temperatures of up to 200,000 degrees. Just behind Scorpius is the constellation Sagittarius, the half-man, half-horse of Greek mythology. Sagittarius can be traced beyond the Greeks to the ancient Mesopotamian archer god Nergal. As we mentioned in last month's Skywatch, the very centre of the Milky Way galaxy is found in Sagittarius, some 27,000 light-years away. Sagittarius is known for its nebulae and clusters more than any other constellation. One of the largest and brightest is the globular cluster M22, big enough to be visible to the unaided eye. Located some 10,600 light-years away near the galactic bulge, M22 is more elliptical than most globular clusters. It's located just south of the ecliptic, the imaginary plane in the sky upon which the planets orbit the Sun. M22 contains some 70,000 stars, covering an area of 100 light-years. It also contains at least 2 black holes, and is one of just a handful of globular clusters known to contain planetary nebulae, the spectacular puffed-off outer gaseous envelopes of dead sun-like stars. Located in the sky next to Scorpius in the west and Sagittarius in the east is the constellation Ophiuchus, often portrayed as a snake coiled around a man. In Greek mythology, it's Ophiuchus which raises Orion from the dead after he's bitten by Scorpius. That's why it's used as a symbol by the medical fraternity. Ophiuchus contains several star clusters and other interesting features, the best of which would have to be Barnard's star. Barnard's star is the second nearest star system to the Sun, beaten only by the Alpha Centauri triple star system. Located some 5.9 light-years away, Barnard's star is a spectral type M red dwarf, only about 0.144 times the mass of the Sun. At between 7 and 12 billion years of age, Barnard's star is considerably older than the Sun, and it may be one of the oldest stars in the Milky Way galaxy. Because of its age, Barnard's star has lost a great deal of rotational energy, and the periodic slight changes in its brightness indicate it rotates about once every 130 Earth days. As we mentioned earlier, the Sun rotates every 28 Earth days. Given its age, Barnard's star was long assumed to be quiescent in terms of stellar activity. But in 1998, astronomers were surprised to observe an intense stellar flare, indicating it's a flare star. Flare stars are variable stars that can undergo unpredictable dramatic increases in brightness in a few minutes. It's believed that the flares on flare stars are analogous to solar flares on the Sun, in that they're generated by stellar magnetic energy stored in the star's atmosphere. Lying just to the west of Scorpius is the constellation Libra, the Scales. In Greek mythology, Libra represents the claws of Scorpius the Scorpion. However, the Romans considered Libra distinct from Scorpius, and saw it as scales symbolising the equinoxes, the times of the year in March and September when the Earth gets equal lengths of day and night. 2,000 years ago, the Sun moved into Libra at the time of the September equinox. But due to precession, as the Earth's spin axis wobbles in direction, this point in time has now moved into the adjoining constellation of Virgo. If you turn to the south in the Southern Cross, you'll find it's in the constellation Centaurus, another half-man, half-horse mythical beast. Centaurus was the teacher of many Greek gods and heroes. He was placed among the stars of the heavens after accidentally being killed by a poisoned arrow fired by Hercules. Close to the pointer star Beta Centauri lies NGC 5139, Omega Centauri, the largest and brightest globular cluster in the visible sky. Because of its brightness, the ancient Greek mathematician and astronomer Claudius Ptolemy originally thought Omega Centauri was a star. It has a diameter of over 150 light-years and contains an estimated 10 million stars, giving it some 4 million times the mass of our Sun. Located some 15,800 light-years away, Omega Centauri is another example of a very ancient globular cluster, around 12 billion years old, and it's one that contains many population 2 stars. Population 2 stars were the second generation of stars to have formed, and they were all created directly out of the remains of the very first stars to shine. Omega Centauri is also interesting because the stars in its core are so crowded they're estimated to be an average of only 1/10 of a light-year away from each other. And that compares to the nearest star to our Sun, which is Proxima Centauri, located some 4.2 light-years distant. Close to Omega Centauri is the giant lenticular galaxy NGC 5128, better known as Centaurus A. We see Centaurus A looking as if it's split in half by a thick band of dust. The galaxy was discovered in 1826 by astronomer James Dunlop from his home in what is now the Sydney suburb of Parramatta, a long time before the bright lights of a modern city would make such discoveries impossible. Located some 13 million light-years away, Centaurus A is one of the strongest radio sources in the sky, and it's thought to be the result of a merger between an elliptical and a spiral galaxy. August is also the time for the peak in the annual Perseids meteor shower. The Perseids meteors are the debris trail ejected by the comet Swift-Tuttle as it travels along its 133-year orbit through the solar system. As the name suggests, the Perseids radiant, the point in the sky from which the meteors appear to originate, is in the constellation Perseus. The Perseids are one of the oldest known meteor showers, with early Chinese historical records of its activity going back almost 2,000 years. It's also a long meteor shower, being active between the 17th of July and August the 24th. But the peak will be on the night of August 12th, with some 60 meteors per hour being visible. The Perseids are also very bright and fast-moving meteors, travelling at speeds of 59 kilometres per second. They're best seen between midnight and just before dawn, producing long bright trails as well as some spectacular fireballs. Most Perseids burn up in the atmosphere at altitudes over 80 kilometres. Because they're best seen from the northern hemisphere, our southern hemisphere listeners will need to look to the low northern skies because the radiant is well below the northern horizon. And now with the rest of Skywatch for the August night skies, here's Jonathan Nally, the editor of Australian Sky and Telescope magazine.
We've been having some really good weather across Australia lately, haven't we? Really clear skies and not too cold. Perfect for stargazing. In fact, I think I read today that certainly some parts of Australia have had their warmest and driest winter, or July at least, for decades, or even on record in some places. So that's been pretty good for stargazers. I don't know about everyone else.
Yeah, warmest July since records first began 150 years ago, and driest July in 22 years. Not that global warming is real or anything like that, of course.
Oh, it couldn't possibly be. No, so that's all a conspiracy, isn't it? The other thing, too, is even though you've got clear skies, it might not still be good for stargazing if you've got a lot of wind, because wind makes the stars twinkle, and while it looks pretty, if you try and look at them through a telescope, it looks awful. You don't want twinkling stars. You want nice, pinpoint, steady stars. Astronomers call this seeing. It's like just like a measure of weather, I suppose. It's like sky weather for stargazing. How good the seeing, in inverted commas, is. Good seeing means you have clear skies, no wind, nice steady stars. Bad seeing is when you've got rotten weather and twinkling stars. Astronomers hate twinkling stars. Poets love it, but astronomers hate it. Anyway, that was July, so we're talking about August now. So looking at the night sky in the evening time, we find the Milky Way stretching across the sky from the northeast right over to the southwest. Really good time to see the Milky Way. In fact, the centre of the Milky Way in the region of Sagittarius is pretty much directly overhead for those people who live roughly at the latitude of Sydney, anywhere around the southern hemisphere. Plus or minus a bit, doesn't matter, but roughly there, sort of mid-latitudes in the south, then you've got the centre of the Milky Way directly overhead. And this is actually one of the reasons why astronomy is so good in the southern hemisphere. It's because we do have the galactic centre where lots of exciting things astronomy-wise are going on. So, unfortunately, our cousins in the northern half of the planet don't get to see that. They can see other things, but they don't get to see that galactic centre. The other things they don't get to see are the two galaxies that we can see down here in the southern sky, the large and small Magellanic Clouds. They're the nearest sizable galaxies to us, so they're good laboratories, in inverted commas, for studying what happens in galaxies out there in space. So we're pretty lucky down here, We've got lots and lots of good stuff to see, including right at the moment.
To see Andromeda.
Andromeda, well, we can see Andromeda low on the horizon. If you've got a good horizon from, say, the latitude of Sydney, you can see Andromeda.
I wouldn't be able to see it anyway because I'm surrounded by tall buildings.
Yeah, look, I remember when I was a kid growing up on the north coast of New South Wales, I did get a couple of glimpses of Andromeda, very, very low down. But yeah, we don't get a very good view of it because it is so low down on our northern horizon. If you live in the northern hemisphere, the States or the UK or anywhere else, then you'll get a great view of Andromeda, which is that's the nearest really big galaxy to us, and a really spectacular sight indeed.
It's getting nearer every day.
Yeah, well, yes. What is it, 2 billion years or something? We're going to go
3.7 it's going to collide.
Oh, good, because I was worried it was only 2.
Yeah, now 3.7, I expect to be covering it live when it happens on SpaceTime.
$10? Right, you're on. Back closer to home, the planet Saturn is nice and high at the moment. It's sort of just to the side of Sagittarius. It's in a constellation called Ophiuchus, which is one of these, what's the 13th sign of the zodiac, but let's not get onto that. But Saturn, yeah, basically is right overhead at the moment too. Pretty fantastic to see. Grab your telescope or grab someone else's telescope if you don't have one yourself and take a look, because the view of the ring planet never disappoints. Now, the largest planet in the solar system, Jupiter, is down towards the western horizon in the middle part of the evening, setting at around about 10 p.m. at the start of August. As the weeks go by, Jupiter will get lower and lower in the sky until by the end of the month it will basically have become lost below the horizon during the middle part of the evening. So now's the time to have a look at it, and take a look on the 25th. If you're having trouble finding which one's Jupiter, take a look on the 25th out to the west, because you'll see the moon there, and right next to it will be what looks like to be a big bright star. Well, that's actually the planet Jupiter, okay? So the moon, as it goes around its orbit, sort of passes by each of the planets in turn, and if you can find the right night where the moon moon is next to a planet, that makes it really easy to identify the planet. So on the same vein, take a look out on August the 30th, and you'll find the moon right next to Saturn, high overhead there. So that's really an easy way to try and find the planet.
And of course, right now, the Southern Cross is pretty high in the southern skies as well.
Yep, it's down there, sort of high in the southwestern part of the sky, lying on its right-hand side. And I know we've spoken about this before, but I'll just remind everyone that the Southern Cross looks like, when we say cross, it's like a crucifix-type cross, not a plus symbol on your keyboard. So it basically looks like a kite, really. When you join the lines of the stars together, it's got a kite shape. And at the moment, it's sort of lying a bit on its right-hand side, down the southwest. And above it are two stars known as the two pointers in the constellation Centaurus. You can't miss the cross or the pointers, really, because they're big and bright and prominent, the only ones really of their kind down in that part of the sky. Now, that's the evening part of the stargazing session. Now, if you're a morning person, there's plenty to see in the eastern half of the sky. That's where the action's taking place. This includes the fabulous constellation Orion, the Hunter, with its bright stars Rigel and Betelgeuse. And it's very easy to see. I never saw that movie. Was that in that movie?
You've never seen the movie? You'll survive.
My life. Well, maybe. Yeah. You know, I didn't even see Terminator.
Hasta la vista, baby.
You know why I didn't see Terminator when it came out?
Why?
Because it had Arnold Schwarzenegger in it. And those of us of an appropriate age will recall that movies that had Arnold Schwarzenegger in it were not really considered to be, very good.
Hasta la vista, baby.
See all these things I missed out on?
You've had a really deprived childhood.
And adulthood, too. And it's still going on. I'm still very deprived.
No!
Yeah, but anyway, where was I? Yes, the morning part of the sky. So, Orion the Hunter, yes. Rigel and Betelgeuse, that's where we were. Betelgeuse, one of the stars in Orion. There's also that very easy-to-see group of three stars in a row, which, when you look at the mythological figure in the sky of the Hunter, that's the belt that holds his, toga or something together. Now, a little way around to the right of Orion, or to the right or south as you're going, you'll find the brightest star in the night sky, which is Sirius.
It's actually two stars you're looking at.
Yeah. Well, a lot of the stars you look up there in the night sky are two stars or more stars, but you don't know that just with your naked eye, and even some of them you don't even know looking through a telescope. A little further around to the right or south still is another bright star called Canopus, which is the second brightest star in the night sky. And the brightest thing of all in terms of planets and stars that you can see is Venus, and it is visible out in the eastern sky in the early morning hours. It's visible all month, in fact, low down on the eastern horizon just before dawn. I mean, you can't miss it. It's so bright. Only the sun and the moon, brighter things in the sky. So that's about it for the stars and planets, but now we've come to eclipses, Stuart, because for listeners in Australia, the Pacific Islands, most of Asia, Africa and some of Europe, there's going to be a partial eclipse of the moon on the night of August the 7th or the 8th, depending on what time zone you're in. It won't be the biggest and best partial lunar eclipse we've ever seen, but about a quarter of the moon will go dark as it moves through the Earth's shadow. So give that one a go on the evening of August the 7th or the 8th, depending on your time zone. And then, a couple of weeks later, on August the 21st, there's going to be the big one for people in certain parts of the world, particularly in the United States, because there's going to be a total eclipse of the sun. Now, this is going to be the first total eclipse of the sun visible from the US mainland since 1979. Believe it or not. It's just the way it happens. Some places get them more regularly, and others you go for a long, long time without getting them at all. So everyone's pretty excited over in the States, I can tell you, because something like 90% of the people in the country live within a couple of hours' drive of the centre line of the eclipse, and potentially can go, hop in your car and go there and see this fantastic event. So that's on August the 21st.
And in fact, if people go to the SpaceTime blog on Tumblr, they'll be able to see exactly how long it will take them to drive from their place to the centre line of the eclipse, because we've got a little map there for people to look at.
That's great. And look, the other thing is too, if you can't drive to see the centre line of the eclipse and see totality, anywhere else in the country there, and in other parts of the world too that will get this eclipse, you'll see a partial eclipse of the sun. So that's pretty good to experience anyway. And the thing is too that if you want to experience the eclipse or the totality and you can't be there on the centre line, well, there are going to be people live streaming over the web, and I'm sure all the TV stations in the States are going to be covering it, particularly for people who get clouded out. Perhaps this is the problem sometimes. You know, you make all these plans years ahead in some cases and keep your fingers crossed that the weather's going to be good on the day. But sometimes the weather gods do not cooperate, and despite all the best laid plans, you get clouded out. So fortunately, in this day and age, we do have all this extra high-tech stuff, which means you can watch it from basically anywhere. Now, this is to do with the sun, of course, so you need to use the standard, sensible solar precautions, which basically means do not look directly at the sun when it's eclipsed or not, with optical aid or even just the naked naked eye. You can get these special little eclipse glasses you can wear. They're fine. There are special filters you can get for your telescopes, and I mean special filters. So if you know what you're doing, you can get hold of those. There are all sorts of urban myths about things you can use to, look through a CD or, exposed
don't risk it.
Camera film. Don't risk any of that stuff. Just do not risk it. You don't want to risk your eyesight. But anyway, all the information you need to look at the solar eclipse or experience it or do whatever you like is available on the Sky and Telescope website. And as you say, on the SpaceTime website.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. And a new study has found that depression can physically change structures in the human brain. The research, reported in the journal Scientific Reports, found alterations in parts of the brain known as white matter. White matter contains the fibrous tracts which enable brain cells to communicate with each other through electrical signals. So that makes white matter a key component in the brain's wiring system. And its disruption has been linked to problems with emotion processing and thinking skills. The study of more than 3,000 people, the largest of its type to date, used a cutting-edge technique known as diffusion tensor imaging to map the structure of white matter in the brain. The findings sheds light on the biology of depression and could help in the search for better diagnosis and treatment. A controversial new app which allows Snapchat users to track their friends is raising concerns among parents and child protection agencies. SnapMap is the latest in a series of monitoring tools built into social media platforms. The so-called stalking software enables users to monitor their friends' movements and determine in real time exactly where their posts are coming from. A report in the journal Digital Journalism points out that SnapMap is just one of many new apps, such as EchoSec, DataMiner, PicoDash, GeoFeeder and SAM. Some of these apps allow social network users to be monitored without their knowledge over time across multiple social networks and with pinpoint accuracy right down to street addresses. And new studies confirm that you'll live longer if you maintain a healthy lifestyle. Maintaining normal weight, not smoking and drinking alcohol in moderation can increase your life expectancy by up to a decade. And the research, reported in the journal Health Affairs, found just as importantly that most of these extra years would be spent in good health. The study, which analysed data from more than 14,000 individuals, found that people who never smoked and were not obese lived for 4 to 5 years longer than the general population, and that these extra years were free of disability. Interestingly, it also found that individuals who consumed alcohol moderately lived 7 additional disability-free years than the general population. While smoking was found to be associated with an early death, it wasn't found to be associated with any increase in the number of years with disability. Whereas on the other hand, obesity was shown to be associated with a long period of time with disability. Excessive alcohol consumption was also found to be associated with both a decreased lifespan and a reduced number of healthy years. However, the absence of all these risky factors was found to be associated with the greatest number of healthy years. Men who were not overweight, who had never smoked, and who only drank moderately were found to live an average of 11 years longer than guys who were overweight, smoked, and drank excessively. For women, the gap between these two groups was found to be even greater at 12 years. The study looked at individuals in the United States aged 50 to 89 between 1998 and 2012. Participants who had a body mass index less than 30 were classified as not being obese. Those who smoked less than 100 cigarettes in their entire lifetime were considered as non-smokers, and men who had fewer than 14 drinks per week and women who had fewer than 7 drinks per week were considered to be moderate drinkers. A new study says wetland protection efforts are overlooking how the environment protects freshwater resources from agricultural fertiliser contamination. A report in the journal Water Resources Research found that small wetlands in Canada have a more significant role to play than larger ones in preventing excess nutrients such as nitrogen and phosphorus from reaching water bodies such as the Great Lakes. Excess nutrients are a primary cause of algal blooms. Algal blooms have numerous impacts, including impairing drinking water quality, robbing aquatic life of much-needed oxygen, and closing beaches to swimming. It turns out while some larger wetlands, which act as a habitat for wildlife, have been protected, smaller ones continue to be removed, making way for things such as new housing subdivisions. What's been overlooked is the different roles different wetlands serve. The study found that small wetlands act as a better nutrient sink than larger ones. That's because a greater percentage of their water touches the soil, either on the bottom or on the shoreline. And that's the key to removing excess nutrients and preventing them from making their way further downstream into larger water bodies. Up to 72% of Canada's original wetlands have now been lost to development such as agriculture and urban sprawl. Women on high-fat diets during pregnancy not only create health problems for themselves, but also mental health disorders such as anxiety and depression for their children. A report in the journal Frontiers of Endocrinology found high-fat diets alters the development of the brain and endocrine system of their offspring and has long-term impacts on offspring behaviour. The study revealed behavioural changes in the offspring associated with impaired development of the central serotonin system in the brain. It also showed that introducing a healthy diet to the offspring at an early stage failed to reverse the effect. Previous observational studies have also correlated maternal obesity with a range of mental health and neurodevelopmental disorders in children. The new research demonstrates for the first time that a high-fat diet, increasingly common in the developed world, had long-lasting mental health ramifications for the offspring. In the United States alone, some 64% of women of reproductive age are overweight, and 35% of those are regarded as obese. The new study therefore suggests that the obesity epidemic in the Western world may be imposing transgenerational effects. Climate change is dramatically impacting on the highly endangered African wild dog population, slashing the survival rates of pups. The study, reported in the Journal of Animal Ecology, is one of the first to show how rising temperatures caused by human greenhouse gas emissions such as coal are affecting tropical species. 3 concurrent studies monitored a total of 73 African wild dog packs in Kenya, Botswana and Zimbabwe over a combined 42 years, finding dogs raised fewer pups at higher temperatures. Tracking using high-tech collars showed that wild dog packs spent less time hunting on hot days. And when the packs tried to raise pups in hot weather, more of those pups died, potentially because they received less food from individuals returning from hunts. African wild dogs are among the world's most endangered carnivores. Their populations are in high decline, with population estimates suggesting that fewer than 700 packs currently remain in the wild. I'm Stuart Gary. This is SpaceTime. And finally this week, a look at the skeptic's view on psychics. The scientific method involves observation, hypothesis, experimentation, analysis and conclusion. Science is all about critical thinking. It's a search for the truth. Don't just take someone's word for it. Test the claim. See if it's factual and stands up, or if it's just a great steaming pile of woo. And that's what the skepticism movement's all about. It's a search for the truth. And remember, scientific facts don't care if you like them or not. Today we'll put the skeptical eye on psychics and clairvoyance. Clairvoyance is the supposed ability to perceive things or events in the future or beyond normal sensory contact. These are people who claim to be able to make contact with dead relatives, famous people from the past, or provide insights into your life and future. Despite the many thousands, possibly millions of claims, there has never ever been a successful demonstration of psychic or clairvoyant ability under normal scientific laboratory-controlled conditions. In fact, the National Committee of Australian Skeptics is offering $100,000 in cold hard cash for any scientifically proven demonstration of such powers. And surprise, surprise, it's a prize which has never been successfully claimed. To paraphrase the Big Bang Theory's character Dr. Sheldon Cooper, who best described psychics and clairvoyance, there's absolutely no scientific evidence to support clairvoyance of any kind, which means psychics are frauds, their professions are swindle, and their livelihood is dependent on the gullibility of stupid people. Iran Segev, President of Australian Skeptics, what say you?
From a lot of experience with people who claim that they're psychics, and so often people who want to be tested to see how well they do, I can fairly confidently say that the majority of people who claim to be psychics really believe that they have those powers. And while there definitely are people who commit fraud or who act knowingly using techniques such as the techniques that mentalists very often use, most of the people who claim to be psychics absolutely truly believe that they have these powers. Most psychic phenomena rely on something called cold reading, which is a technique that can be applied consciously, but can also quite easily be applied unconsciously or subconsciously. So it is possible for a so-called psychic to be using this technique, not knowing that they're actually doing it.
Okay, so let's talk about cold reading. What is it?
Well, it's a technique that allows a person, a psychic, to create the impression that they provide information that they could not possibly know, while all the connections are actually made in the subject's mind. So it's made of several techniques. The most common ones are, for example, Barnum statements. Barnum statements are statements that sound really specific but can actually apply to anyone. For example, I could say to you, you have a box of unsalted photographs at home that you haven't looked at in a while. That is so extremely likely to be true that it's just a safe bet. Or another example is, you've had a disagreement with your brother or sister.
You've had a disagreement with a family member, haven't you?
With a family member, yes.
And by following that line of questioning, you can further narrow in on what the subject really wants to talk about anyway.
Absolutely, depending on how they answer. There's also a lot of guessing. They would say it's something like, I see an older woman. Well, of course you see an older woman. There's older women in everybody's life, or in almost everybody's life. I see a woman and her name starts with a J or a G, but I also see an M. That could basically apply to anyone. The thing is, the psychic doesn't actually know what's going on. The subject is the one who's making all the connections and say, oh yeah, my mum was Jane, or my auntie was Jane, or whatever. They are the ones who find the connection and make it for the psychic. Another technique is something called a rainbow ruse, where you say something that will by definition apply to everyone. You say, you're usually a happy person, but at times events wear you down.
That sounds almost like some of the hokum you get with horoscopes.
That's exactly what it is. That is exactly it. Horoscopes are cold reading. So it's absolutely completely true. The thing is, what's common to all of these things is that the person who's sitting there, first of all, they're sometimes called the sitter, sometimes the subject, they actually want it to work. They try to make the connection. And then there's a psychological phenomenon where people remember the hits. So they remember the times that it sounded accurate, but they forget all the times that it wasn't accurate. For example, they will misremember how many guesses the psychic made. So, for example, they say, oh, yeah, they did guess 2 or 3 names where it could be 20 or 30. And we have recordings from such events where there's such huge mismatch between what the sitter remembers and what actually happened.
That's confirmation bias, isn't it?
Yes, that's exactly it. You don't generally go to a psychic expecting to be disappointed. You go to a psychic because you want to hear something. So you want it to work and you make it work. And what happens from the psychic's perspective is that they get confirmation. They are told that it works. So next time they try something a little bit different and it works too. And it's all quite natural and it's conversational in nature. So cold reading can very easily be applied without being a fraud. And I believe that most psychics, definitely, the small psychics that, that charge $50 for a reading or something like that, are not frauds. However, there are the big stage psychics who very often do things like hot reading. For example, psychic was caught red-handed doing hot reading.
What's hot reading?
Hot reading is when you collect information in advance about the people in your audience and then you spout it back at them. There's no guessing there. You actually know that you're going to get hits. And that is fraud. Maybe not from a legal perspective, but it is definitely cheating. And there are several such psychics that we know because we sit in the audience watching them and we know the tricks. We can see what they're doing. They actually apply tricks of the trade of mentalist magicians. Mentalist magicians pretend to be psychic, pretend to have powers, but actually do things that are very persuasive and really actually a lot better than most psychics.
So what sort of things should we look for?
Well, first of all, look for general statements of the kind that I mentioned earlier.
Cold reading statements, yeah.
Cold reading statements. It would be very difficult for somebody who's not well versed in magic to notice things that are done well on the stage by somebody claiming to be a psychic if they're well trained in doing mentalism tricks. Because if they're good at it, the whole point is to hide it well. So I would say generally if somebody claims to have psychic abilities, they have to provide very specific information and they have to provide it in a way it can't come from somewhere else. And it's important to say that sometimes when it looks like they do that, however, on further investigation or under test conditions, they fail. And that is actually very important to know that there are prizes.
Skeptic societies around the world have huge pots of money available for any psychic who can actually prove they're a real psychic, and no one's ever claimed them.
No, and in fact, not a lot try. So James Randi had the James Randi Educational Foundation when they offered $1 million prize for anybody who can prove paranormal abilities under test conditions. There have been many claimants over the years, and none have even passed the initial test. The Australian Skeptics, the organization that I'm the president of, we have a $100,000 prize plus a $20,000 prize for anybody who refers somebody who actually wins our prize. So there's a pot of $120,000,
folks.
It's money to be made there for anybody who actually manages to show under test conditions that they have these powers.
Describe test conditions.
The point of the test conditions is not to have the person fail, is to ensure that what's happening is the real deal. So, for example, if we test a psychic, we want to make sure that they can't get the information from anywhere else but through their psychic abilities. So we work with the claimants to make sure that the protocol for the test is fair and acceptable to both us and them, and then they fail.
And what are the protocols?
It's easy to calculate the statistics for the protocol. So, for example, we don't accept general statements. It has to be things that are specific, measurable.
So again, I see a woman in your life. That's too general.
That is absolutely too general. What we need is things that we can say yes or no. So, for example, specific dates would be fine. Numbers are fine. Images, to a certain extent, are fine. We have to define the parameters within which we would accept those. We also have to make sure that not only is it measurable, but it's also possible to calculate the odds that we would get a positive result by chance alone. And that obviously happens. If you flip a coin and you guess something, or you guess heads, half the time you will get it right by chance alone. It's not because you know it. It's because that's the way statistics work. So we have to make sure that we don't get a chance positive result too often. So generally what we say is we want a probability of 1 in 1,000 for the initial test and 1 in 1,000,000 for the full test. But as I said, nobody's ever gone to the full test because they always fail the initial test, the 1 in 1,000 test.
Have there been many people try to claim the prize?
So with Australian Skeptics, we have over the years probably had a few dozen claimants, and that is in addition to...
Any famous ones?
No. The famous ones don't do that because the famous ones generally know what they're doing. They have a lot to lose by doing this kind of test. The fact that nobody's ever passed suggests to them, even if they do believe it, which very often I suspect they don't, even if they do believe in what they do, the risk for them is too high. They already have the RSL stages, and why would they come and risk their reputation by failing a skeptic's test?
Why prove you're a fraud when people can only just speculate about it?
Well, I think it's worse than that. They can always claim that they're not frauds, that they didn't have a good day or whatever. There's just nothing for them to benefit. There's absolutely no reason for them to do it. However, we obviously have small-time psychics of various kinds that we test, and so far nobody's ever passed the first stage.
Do you put psychics in the same category as mediums?
Nowadays, psychics is quite a generic term, but very obviously, mediums very often call themselves psychics. Mediums communicate with otherworldly beings such as ghosts or angels. In the past, we had these channeling, which was a very big thing in the 80s. Famous case where Randy brought Carlos to Australia, and Carlos was obviously a hoax, but he was not picked up by the media, which reported it very gullibly until Richard Carlton, I believe it was, broke the news that this was all a hoax. One thing that psychics really love to use is quantum mechanics.
Quantum, it's all quantum, yes.
Oh, absolutely. Absolutely. It is this kind of very strange thing. It's spooky. Even Einstein said that it was spooky, and it's something that very few people in the world understand, and psychics obviously don't understand it, but it's good enough that it sounds sciencey and that other people don't understand it, so you can pin a lot on it. And it is extremely common for psychics to say things like, quantum physics has shown us that we can be in two places at the same time, or some other piece of silliness such as that. So they love it because it gives them an excuse for a lot of their claims.
That's Iran Segev, President of Australian Skeptics. This is Space Time. I'm Stuart Gary. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts or Audio Boom. This has been another quality podcast production from Bytes.com.